Hello, bonjour. My name is Manuel Bringué, and I will be providing you with a quick update and overview of Project MOSS, which stands for Marine Oil Spill Studies. The project focuses on Douglas Channel, which is a large body of water on British Columbia's north coast. It connects the active port of Kitimat to the open waters of the Northeast Pacific Ocean. Kitimat is an active port, and there are a number of existing and planned energy projects that essentially would export energy resources, in particular natural gas, to international markets. Now, what does that mean? It means that locally, in the decades to come, it is likely that tanker traffic will increase quite dramatically. The objectives for this project are, first of all, to establish a robust baseline of natural variability in Douglas Channel, for instance, in terms of temperature and productivity, and that on seasonal to millennial timescales. So we want to have a good idea of what the natural variability in the system is like. And then we want to estimate the capacity of microbial communities to mitigate accidentally released petroleum products. And we will specifically test conditions of reduced oxygen concentrations and lower pH. So this is with the global trends of ocean acidification in mind, as well as reduced oxygen concentration, particularly at depth. The team is fairly large and includes several GSC scientists from coast to coast. And we are also lucky to have several collaborators from other government organizations such as DFO and NRC. And we also have Vera Pospelova from the University of Minnesota with us. Now, for a quick overview of the project, there are three main phases to the project. The first one is a sediment trap study. Sediment traps are devices that are typically deployed within the water column, and they intercept sinking particles such as sediment particles, as well as the remains of the microplankton. In particular, we're going to use a palynological approach. Palynology is the study of organic walled microfossils, and in particular here, dinoflagellate cysts will be particularly useful in informing on the natural variability in the system. So palynology will be used in conjunction with geochemical indicators as well. So this sediment trap component can be viewed as a calibration effort. We are calibrating the signals from the water column that we will find later in the sediment archives underneath. Second phase consists in the study of sediment cores. So sediment cores are basically archives as the sediment accumulates over time. It keeps a record of whatever was happening in the water body above it. And so we have a set of short cores as well as longer piston cores. The short ones typically span about a century or so, and the longer ones cover the whole Holocene, so 12,000 years or so. So those cores will be used to reconstruct past environmental variability in the system, and possibly we may be able to trace some human impacts as well from the short cores. And so again, here we will use palynology and geochemical indicators. Third phase of the project consists in microcosm experiments. So these are lab-based experiments, basically in Petri dishes, where we will test the capacity of microbial communities, both from the water and the sediment, to degrade some petroleum products. And we are going to test specifically how efficient they are or not efficient when it comes to reduced oxygen concentrations as well as lower pH conditions. So we have selected several sediment samples. We were lucky to have all of this material available through the Pacific Geoscience Center and DFO, so we are very grateful. No new sampling had to be conducted for this project. So we have selected a sediment trap data. So DFO is providing us with about 3 years worth of data from station FOC1. We have a set of 3 box cores, so one that is at the same station than the sediment trap, and then further down the main axis of the channel, close to the wreck of the marine vessel Queen of the North, and another one further out in Squally Channel. We also have 2 piston cores that cover the whole Holocene. So one is very close to the head of the inlet in Kitimat Arm, piston core 23, and piston core 18 is also located close to the wreck of the Queen of the North, closer to the mouth of the system. In terms of analysis, we have some geochemical data already available to us, and a lot of it has been already sent to respective labs. Palynology is underway in GSC Calgary for all the sediment trap samples as well as the sediment cores. Dating of all the sediment cores has already been completed as well, and we have some further geochemical analysis planned for this year, as well as the phase 3, so the microcosm experiments. All of this is planned for the following year, so fiscal year 3 and 4. Dialogue with the Gitgat and Haisla nations was initiated in 2018, and we are hoping to have some yearly in-person meetings if travel is possible. This is particularly important to determine together which petroleum products to put to the test in the microcosm experiments. Here are our contact information. Thank you very much and have a great day.